Hi everyone, so today's lesson we're going to be focusing on something called natural logs. Now over this entire week we're going to be covering E. Yesterday we went over the natural base, which was E, so that's going to be covered throughout the entire lesson this week. So the first thing we're going to do is a little homework review. And in the first problem I gave you yesterday, it said the relationship between the elapsed time D in days since the video was first uploaded and the total number of views, VD, that the video received is modeled by the following function. VD is equal to 10 to the 1.5 times D power. So we want to know how many views will the video have after 16 days. Now the nice thing about these problems is there's basically really only going to be one spot for you to plug in your number. The only thing that could be a little tricky for you guys is you just have to pay attention to what the variable is being measured in. In this problem, I'm telling you, time is in days. So if I gave you, just say for instance, 16 weeks, you'd have to convert 16 weeks to days. So here, I gave it to you already 16 days, so we don't have to worry about converting. And as a little reminder, there are 7 days in 1 week. So the first thing. So here's our equation. VD is equal to 10 to the 1.5 times D power. What did we want to know? We wanted to know how many views would there be after 16 days. So we're going to just plug 16 in for D. So VD is equal to 10 to the 1.5 times 16 power. Now over here on the left-hand side, it says V of D. Now there's another D. You can, in theory, you're supposed to put the 16 there as well, because then it's telling you the views after 16 days. Now I know some of you guys get confused with seeing the number here and the number here. So for me, I have no problem with you guys just leaving it VD because I'll know what you guys are solving for. So just leave it blank or just leave it as a D if it's going to throw you guys off if you plug the 16 over here. So all we do is plug in for D, 16 in for D, and then what we're going to do is the first thing I like to do, make it easy, because remember our calculators, as smart as they are, the second you do something to an exponent power, if you're going to be multiplying, subtracting up in that exponent, we have to make sure we close the parenthesis. So I don't have to worry about that. I like to just simplify the exponent first. So I multiply 1.5 times 16 and I get 24. So our new equation now is 10 to the 24th power. So I put 10 to the 24 in my calculator and I get 1 times 10 to the 24th. In your calculator, it will say 1.0 E24 or 1 E24. That's all that means. So anytime you see E, that means it's 10 to the whatever power. So after 16 days, we will have 1 times 10 to the 24th power views. Some of you guys went out and actually wrote out 24 zeros. Completely up to if you really wanted to count out 24 zeros, you could go ahead and do that. I'm fine with getting the answer like this from you guys. The next problem. Carlos has taken an initial dose of a prescription medicine. The relationship between the elapsed time, T, in hours since he took the first dose, and the amount of medication, MT, in milligrams, in his bloodstream is modeled by the following function. So what they give you the function as MT is equal to 20 times E to the negative 0.8 times T power. So I want to know, how much medicine will Carlos initially have? And if you remember from yesterday, anytime I'm talking about initial is always going to be 0, not 1, 0, because we want to know how much is there originally, and the only way to figure that out is our T would have to be 0. So to figure it out for how much there is initially, same thing. T is going to be 0, and I'm just going to plug in for T. So I do 20 times E to the negative 0.8 times 0. So the first thing, what we're going to do is we simplify the exponent. So we're going to multiply negative 0.8 times 0. And when we do that, we get 0. So now we're left with 20 times e to the 0. So now I like to just get rid of the e's first. I know some of you guys have the nice fancy calculators. You could throw this all in at once. Completely up to you. But for what I like to do, and I advise you all do the same, solve this e first. So we're going to do e to the 0 power and then multiply that answer by 20. When we do that, we're going to get our answer as 20 milligrams initially. Now for the next one, I wanted to know how many milligrams will there be after 12.5 hours and after 3 days. Since our t was measured in hours, I have to convert 3 days to hours, which is 72 hours. So first thing that we're going to do is mt is equal to 20 times e to the negative 0.8 times 12.5. We're going to solve for 12 and a half hours first. First thing I do is I like to simplify this exponent, so I'm going to multiply negative 0.8 times 12.5, and I get negative 10. Now the next thing I like to do is I like to do e to the negative 10 power. So once I get that answer, I'm going to multiply that by 20. Once I get that, I get 9.079 times 10 to the negative 4 after 12.5 hours, or some of you in your homework did do this. You move the decimal point 4 places back to the left. So you would get 0.00, which should be another 0 over here, 0.0009079 milligrams after 12 and a half hours. Next, I wanted to know how much is there going to be after 72 hours. So same thing, I'm just going to plug 72 in for the exponent. So we have, so once we do that, we do negative 0.8 times 72, and we get negative 57.6. So now I'm going to solve. I'm going to do e to the negative 57.6 power, get an answer, and multiply it by 20. Once we do that, in my calculator, I get 1.9305 times 10 to the negative 24th after 72 hours. So basically what this is telling me is after 72 hours, when you have something to the negative 24th exponent, that's going to be so tiny. So basically after 72 hours, that drug is no longer in that person's bloodstream. So for today's lesson, what's a natural log? Well, here's the actual definition of a natural log. We're going to break it down step by step what this means. So when e to the y is equal to x, then the base e logarithm of x is ln of x is equal to log base e of x is equal to y. Okay, now some of you are sitting there going, okay, I have no idea what this even means. So basically, summarize all this together. The base for natural logs is e. So anytime I tell you natural log, we're going to be using e. Taking it one step further, we're going to go over this in a couple examples. When you see log base e, so whenever you see log with e right over here, you're going to replace it with ln. So log base e is equal to ln, and it works the same way. The others works the same way. ln is also equal to log base e. So this is key. As long as we remember this right here, we'll be set. So since we're working now, we know where the log button is on our calculator, but now we're going to be working with ln. So where is the ln button? Right underneath log. It's right underneath log. I circled it right here. So as a little reminder, log form. So we're going to have log. Then our base is going to be as a subscript, so it's going to be tiny down here. Then we're going to have our answer, and it's going to be equal to whatever that exponent initially was when it's in. Now this is log form. This is when we're converting from exponential to log form. This is exponential form. We're going to have our base raised to our exponent is going to give us an answer. So the first problem, convert the following to log form. Okay. We know already how to convert to log form because we spent a whole week on that and we've already had a quiz on it. So I give you, the only difference now is instead of a number over here, I give you e. So now I have e squared is equal to 7.389. Okay, first thing, we want to put it into log form. So as a reminder, our log form is log, then our base, then our answer is equal to whatever that exponent was. So in this problem, e is our base, 2 is our exponent, and 7.389, that's our answer. So we're going to plug this into log form. So all of this, what we had over here, we're just going to plug it in. So log base e of 7.389 is equal to 2. Once we get that, we're not done just yet. Technically, it's in log form, but when we see log e, we don't like to have that. So we want to get rid of it. Log base e, we can replace that with ln. So as long as remember, whenever we see log base e, replace that with ln. So I go ahead and I replace that. So now I'm left with ln of 7.389 is equal to 2. Now this right here, this is your final answer. Don't keep it as log base e. That's not, when we're working with e, if you give me this, you're like 99% there. This is the 100%. On a quiz or a test, if you left this log base e, you'd lose some points on it because it's not the best and that's not the final answer. The final answer would just be replacing log base e with ln. That's the only difference here, converting this to here. This is technically log form because this is the natural base. So let's try this one. E to the 0.4 power is equal to 1.492. Okay, e is our base, 0.4 is our exponent, and 1.492, that's our answer. So now we just plug it in. So we have log base e of 1.492 is equal to 0.4. Okay, we're comfortable with doing that. Is that our final answer? No. What do we got to do? Well, we got to replace log base e with ln. So now once we do that, our final answer is ln of 1.492 is equal to 0.4. This is now your final answer. Okay, so now we've converted exponential to log form. Let's work the other way. Let's convert our log form to exponential form. So we have ln of 6.7 is equal to 1.9. Well, so I rewrite it, ln of 6.7 is equal to 1.9. So some of you are going to say, well, Ms. Bogdan, how can I convert that to exponential form? I don't have a base. Well, remember how I told you? Log base e is equal to ln. It works the same way. So ln is also equal to log base e. So now I can replace ln with log base e. So now I write log base e of 6.7 is equal to 1.9. Remember, exponential form goes base to our exponent is equal to our answer. Okay, so back over here. We have log base e of 6.7 is equal to 1.9. E is our base, 1.9 is our exponent, and 6.7 is our answer. So I go ahead and do that. E to the 1.9 power is equal to 6.7. Now, a little way, if you guys get confused about this, like how do I know where the exponent goes versus how do I know where the answer goes? Okay, so if my mouse wants to work, okay. So down here we have E, right? If E is going to be our base, so if we circled E and then drew an arrow coming up around this way, we're going to circle around there. That would be your exponent, and then so circle, bring it around, start wrapping around, exponent, and this is our answer. So now we're going to take it even one step further. Now we're going to be solving for x. So now we have e to the x is equal to 5. E to what power is going to give us 5? The first thing that you guys should do, it's easiest to convert it to log form. So let's just convert it. So we have, this is our base, exponent, answer. So plug it into log form. Log base e of 5 is equal to x. Well, remember I told you whenever you see log base e, replace that with ln. So now we're left with ln of 5 is equal to x. Well, to make things even simpler, now all we have to do is we have the ln button on our calculator. Hit the ln button and put 5. Once we do that, we'll get 1.609. Let's round it to 2 decimal places. So we get 1.61. So x is equal to 1.61. Now, if we wanted to check it, we would do e to the 1.61 power. And we probably get as really close to 5 as possible. It might be like 5.000, or it might be like 4.999. The only difference is because we rounded over here. So all we did here was put this into log form. So then we got log base e of 5 is equal to x. Whenever you see log e, replace it with ln. So we did ln of 5 is equal to x. You just did ln. Some of you are going to be inclined, well, how am I going to put the x in the calculator? You're solving for x. We're not going to put x in the calculator. So you just type in ln of 5, and it's going to give you an answer. And our answer here, x was equal to 1.61. So let's try this one. E to the x is equal to 25. So first thing, put it into log form. Log base e of 25 is equal to x. We have log base e, replace that with ln. So now we're left with ln of 25 is equal to x. Do ln of 25 in our calculator, and we get x is equal to 3.22. Now here, what about if I give you something like this? ln of 54.6. Well, you're going to say, there's no x for me to solve there. What am I supposed to do? If I give you a problem that looks like this, all you are expected to do is hit the ln button on your calculator and type in 54.6. When we do that, ln of 54.6, it will give us 4.00. That is your final answer. That's all you have to do for problems like that. Some of them, as in these ones over here, they're a little more involved. This one is pretty much straightforward. You just plug it in your calculator, get an answer, and write that answer back for me. So as always, here is our pet of the day. So this right here, this is Chopchi. Chopchi is Miss Sekanella's dog. He's 10 years old, and she says he is the best dog ever. They got him around 10 years ago. He is a world traveler. He has traveled the world with the Zekanella family. He's so cute sitting in his little suit and tie over here. So, as some daily reminders, your homework is assigned daily and it's posted on Google Classroom and Plus portals. Upload it to Google Classroom or email it to me, but it has to be before the start of class. If I don't get it before class, it's considered late and you will not receive full credit. On Friday, May 8th, you will have a quiz on the material covered so far this week. So basically, it's going to be on the natural base and with E. And then on Tuesday, 5/12, your test packets are due. Now, I've gotten a couple questions from seniors on how the rest of this marking period is going to end. You guys are finished with school or with classes on May 15th. That's your last day. So you basically have about a week and a half left. What I'm going to do is you're going to get a quiz this Friday, May 8th, and then you're also going to have a quiz sometime next week, and then you also have your test packet due to me on Tuesday. So there's 3 more test and quiz grades that will be going in. So 2 quizzes and 1 test, and then you'll also have homework and classwork assigned between now and then. I'm going to be, if I haven't already done so, I'm going to be reaching out to you guys with your missed assignments. Please make sure we're handing those in on time. If you guys have any questions, please be sure to email me. Have a great day, guys.